Hello, my name is Henry Chen. I'm a professor of electrical engineering at Wright State University. Electrical engineering has tremendous impact on our society in the past, present, and the future as well. We are trying to make our major more accessible to more people, and we are excited that you are interested in taking the next step in your educational journey with electrical engineering at Wright State University. First, let me introduce you my background. I graduated in BS Electrical Engineering from the National Taiwan University, Taipei, Taiwan. Taiwan is situated in the West Pacific between Japan and the Philippines. Taiwan is about 3 times smaller than Ohio, but with the population of some 23 million, Taiwan is many people's favorite place in the world, and I hope you have chance to visit Taiwan someday. I received my MS in Electrical Engineering from the University of Iowa City, and a PhD also in Electrical Engineering from the University of Minnesota, Minneapolis. I'm not a professor of electrical engineering. I joined Wright State in 1989. Here are the courses I taught at the Wright State University, which are pretty much related to my research area, VLSI, FPGA, and Embedded Systems. I have supervised over 60 graduate students and published with my students for research publication over 120. Digital revolution. This is the age of digital revolution. The system on a chip, SoC, is perhaps the most important component present in a smartphone. SoC not only comprise up of the smartphone's CPU, modem, display processor, video processor, but also the GPU. Here, including the VLSI technology as well as FPGA technology. And we are in the age of continuing digital revolution. Not only smartphone, smartwatch, smart glass display, smart car, even we talk about smart newspaper. So how smart is smart? New smart products every year continue digital revolution. To cope with this digital revolution age, Wright State EE offers several digital technology courses, which are classified into 3 areas: VLSI, FPGA, and Embedded System. Our EE major can take 2,000 and 4,000 level courses, and our EE senior 4+1 students can take 7,000 level courses and receive master's degree in 1 year after BSEE degree. All courses are designed to help you learn from the fundamental to advanced technology. VLSI courses. Here are the 5 VLSI courses. FPGA, 4 courses. Embedded System Design, 4 courses. Now I want to talk about the detail of VLSI courses and give you some idea what Wright State can offer. The first one is the digital design with HDL. We start to introduce students the ICE, integrated circuit I/O pin and logic design, digital design steps, FPGA device, combination and sequential logic design and optimization, how to write a VHDL design, and also the test bench to do the functional verification and also synthesis. hardware implementation using the Xilinx FPGA device Z-Ball. For example, here is the decoder, and here is the 7-segment LED display for digital watch and alarm. All this design can be implemented and tested in the FPGA device. After the year 2000, we introduced VLSI design. This class teaches students the process of designing a digital system as a full customer integrated circuit, from device concept to circuit concept to layout for fabrication, device operation, and also CMOS transistor serial and CMOS circuit design, function delay, and power simulation will also be addressed. In parallel, we teach students IC hardware security and trust. Today, the semiconductor IC fabrication process have made integrated circuit increasingly vulnerable to Trojans. Hardware Trojan, for example, additional hidden functionality are designed and built in for hostile purpose. And the third-party IP can be soft IP, hard IP, and from IP. So designers today must expend effort to detect Trojans and verify trust in IP core and IC design as well. Low power VLSI system design. Why low power? Look at the semiconductor technology roadmap in industry. You will see that the power train compared with the power requirement here, almost 7-to-1 ratio. So this class here will cover real-world system design issues, such as high-performance VLSI subsystem design, physics of VLSI power consumption, interconnect modeling and signal integrity, low-power VLSI circuit family, timing constraint, memory design, even architecture-level power system. In parallel here, we teach the VLSI teaching and design, VLSI testing and design for testability here. Why VLSI testing and testable design? So here is the example showing that the IC manufacturing equipment cost. So total test equipment cost here almost 7 to 8 times of the total assembly and fabrication cost. So the quality of the shipped product coupled with the growing complexity of digital design require testing issue to be considered early in the design process, so the design can be modified to simplify the testing process and reducing the total cost. Students not only learn VLSI testing and testable design, but also learn the board level boundary scan and the system-on-chip test standard. Now I want to shift to the FPGA courses. Other than EE 2000, we introduced the digital integrated circuit design with programmable logic device and FPGA. This course emphasis is placed on top-down design methodology, beginning with the pure structural VHDL and then behavioral VHDL description. We begin by developing VHDL skill and technique for design digital combinational and sequential circuit, as well as the pipeline design. Then we cover the introductory topic in field programmable gate array circuit design, and we study the digital signal processor and the finite state machine controller. And all the practical design implementation can be implemented and tested in the FPGA device. digital wideband receiver design. This course is considered fundamental from a theory and practice in applying digital techniques to ever increasing bandwidth in a wideband receiver. To design a receiver with high sensitivity, high dynamic range, and high time and frequency resolution, the digital signal process can be very complicated. A student learn many effective design techniques based on our study and research. In parallel here, we also offer the VLSI design synthesis and optimization, and the emphasis is placed on digital logic and system design. The topic including the multi-level logic, optimization, topology mapping, finite state machine synthesis, decomposition, retiming, microprocessor cycle buffering, and also the RTL behavioral VHDL synthesis from the algorithm to hardware and then to functional verification. Finally, I want to shift to the embedded system courses. Embedded system is the information processing systems embedded into a large product. And many of these information systems are commercial VLSI and FPGA products. For example, car is an integrated control, communication, and information system. Wireless communication, mobile phone, wireless local area network, end-user equipment like Wi-Fi and a router also is an example of embedded system. Embedded system courses include computer organization, microprocessor-based embedded system, and also advanced embedded system. Again, thank you for watching this video, and we are excited that you are interested in taking the next step in your educational journey with Wright State University. Should you have any question regarding our curriculum and also future career, please feel free to contact me. And finally, I wish you all the best.